cloud chamber. You guys about to show how it works. So it's got a cover there. You take the cover off and set it down. Set it, yeah, that's fine. Now that pan is the evaporator pan, and we have a couple bottles of alcohol, a couple lights, and the tank. So we take the tank off, and we put a couple pieces of dry ice on the pad. And put your source, your uranium.
Where is that?
I think it's inside the terrarium.
Oh.
Put it about the middle.
Just want that listed.
Okay, now that's good. It'll melt in a second. Now the next thing you want to do is you want to put some isopropanol in there.
You got a paper towel?
No, just put it on the felt.
Oh, you don't want me to put it on the bottom?
No. Good. When you invert it, turn it toward the back so the alcohol doesn't drip down the front. But you have to have the open facing the front, so you got to turn it around. There you go. Now set it in there carefully, right in the corner. Don't set it too hard on the aluminum. You got to set it in the aluminum.
How exactly am I supposed to?
Fits exactly in, so we got to.
Oh, okay, it fits in the aluminum.
Yes.
Ooh,
You got it?
cold.
There we go. So now it is in place,
Hey, you might
and
want to step on
the
that.
vapor chamber, it will. Thank you, honey. It will start to evaporate in a minute, and we'll be able to see in there when we turn the lights on. We'll be able to see some elementary particles creating condensation trails through the
So what's
supersaturated vapor.
really happening here? Well, one way to explain it is to look at this image here. What we have is a chamber where there's alcohol vapors at the very top, and then at the very bottom, because of the dry ice, we have liquid alcohol. And in between the vapors and the alcohol liquid is this transition zone. It actually looks quite a lot like rain. And that's where the particles can be seen, in that transition zone. When ionizing radiation from space or from Eli's piece of uranium ore enter the chamber and enter this supersaturated region, the ions that ionizing radiation creates act as nucleation sites for the condensation of the alcohol vapor. What this does is it gives the alcohol vapor a trail. It gives that ion a trail that runs through the condensation chamber. Depending on what kind of ionizing radiation enters that chamber, you get a different kind of condensation trail. So alpha particles make this wide condensation trail. We don't see many of those. They're high energy particles from outer space. Then there are protons and electrons that enter, and they make different kinds of trails. And the lower energy particles will actually not be straight. They'll bounce around in there a little bit until their energy is reduced below the energy required to ionize the molecules in the chamber.
So you're looking at some particles emanating from the uranium ore. The ones that are curvier are lower energy particles, and the ones that move straight are higher energy particles. Especially you can see alpha particles very well because they're basically helium nucleuses moving really, really quickly through the air. So if you light from the side, you'll be able to see the particles better than if you light from the top. You're about to see a top view of it, which is you can see the particles a lot better, and you can see a lot more of them, and especially where they are. A lot of them are pointing away from the rock, but some of them are actually coming from space or from other sources in the house.
You're right about the view, Eli. This is a top view, and you can totally see a couple of interesting effects here. One is you see the trails really clearly. And the second is you see this rain. Do you see the rain coming down on the... it looks like the bottom is moving, but it's actually the alcohol raining down into the condensation layer.
Yeah, I can see it. It's really quite interesting. You can also see all the currents inside the box caused by the differential between the dry ice and the heater pad on the top of the box.
That's very cool. And you can, some of these trails you see are sort of, they seem disassociated with that piece of uranium ore you have, and some of them look like they're emanating directly from it. The ones that seem to be disassociated, those I think are actually coming from space, and the ones that sort of radiate out from the piece of ore itself are actually being emitted by the uranium ore. What I find interesting, or I guess there's a question I don't really know the answer to, is you can see the trails move as if the particle is moving through the vapor chamber, but it's hard for me to know whether that's actually the speed of the particle or is that the speed of the condensation.
Well, I mean, you know how with airplanes you have the speed of sound. Um, when they break the sound barrier, it actually moves past its own wavefront. I think the same thing is happening here. There's a certain speed at which the alcohol can condense, and that delay is what you're seeing.
Yeah, you could be right. It'd be interesting to find out the actual answer to that question, because it seems like some of these particles are moving really slowly and others move very quickly. And I think if we were ever able to figure out the lighting, we'll get some better lighting at some point for this chamber. I think we're going to see a lot more trails. You can see some of them here, but for the most part, I think we're missing the large majority of them.
Well, you notice how they appear instantaneously, or at least most of them. I think the ones that appear instantaneously would be your alpha particles and your protons, but the ones that sort of take a little while to appear from end to end, I think that would be your electron, because electrons don't actually move that quickly relative to space.
Well, this was a lot of fun to build this chamber, and I hope we have a lot more fun fiddling with it and trying to perfect sort of what we're doing with it and how to show as many trails as we can. But so far, I think we're having some pretty cool effects, and we've had some great luck being able to visualize some of these nuclear particles sort of whizzing around inside our chamber.